Every once in a while in the AI world, something lands that isn't just another update. It's a real fundamental shift in how these things actually think. And that's exactly what we're digging into today. A new model from Meta called VL-JEPA that might just change the entire game. So let me just ask you something to get us started. We all know the big players, right? ChatGPT, Claude, Gemini. We think of their superpower as their ability to generate language. But what if that very thing, the act of predicting words one by one, is actually what's holding them back?
Because that's the core difference we're talking about. The old way is all about predicting the next word in a sentence. It's a language game. But this new architecture, VL-JEPA, it basically throws that entire playbook out the window. It doesn't predict words at all. It predicts meaning directly. And believe me, that changes, well, everything.
All right, so first, let's really break down the core issue here, what I'm calling AI's big word problem. It turns out that forcing an AI to think in words is, and this is kind of surprising, incredibly inefficient. Okay, to make this super clear, let's try an analogy. Imagine you show an AI this picture. Someone's flipping a light switch. And you ask a simple question. What happens next? Now, you and I know there are tons of ways to answer that, right? You could say, the light turns off, or the room goes dark, or even the lamp stops working. They all mean the exact same thing. But here's the catch. For a traditional language model, those aren't one answer said three ways. No, they are three completely, totally different answers, different words, different sequences. The AI has to burn through an insane amount of energy learning every single possible way to phrase the same idea. It's basically memorizing style instead of actually understanding the main point. And this is where VL-JEPA comes in with this really elegant solution. It solves this whole problem by just skipping the words. It jumps straight to the meaning underneath. So, how does it do that? It operates in something called an embedding space. The easiest way to think about this is like a meaning map. It's a place where ideas that mean the same thing are clustered right next to each other, no matter what words you actually use to describe them. And this is where the magic happens. In that old word space, our sentences, the light turns off and the room goes dark, are like, they're miles apart because they use different letters. But in meaning space, boom, they're right next to each other because they represent the same core concept. This takes a super messy problem and makes it clean, simple, and way easier to learn. Okay, so how does this thing actually work? Let's take a quick peek under the hood at the JEPA engine. There are basically four main parts that make this whole thing possible. First, you've got a vision encoder that turns the picture into a representation of its meaning. Then, the predictor. This is the brain of the operation. It predicts the meaning of what happens next. There's a target encoder that helps with the training. But check this out, step 4, the decoder, it's barely even used. Most of the time, this model is just living in this abstract meaning world and never even has to bother with human language. So what does all this abstract stuff actually get you in the real world? Well, it all boils down to being faster, way more efficient, and surprisingly, a lot more versatile. Just look at this chart from Meta's own research. On a video captioning task, the VL-JEPA model, which has only half the parameters of a traditional model, performed almost twice as well. It learned faster and it scaled better. That's not just a little improvement, right? That is a massive structural advantage. But really, the huge payoff here is speed. Because the model is always working with meaning, it can use this cool trick called selective decoding. So instead of spitting out text every single second, it only translates meaning into words when something important actually changes. For things like a robot or smart glasses, that means a nearly threefold drop in the work it has to do. That's a game changer for real-time applications. And if you put it side by side with the model that used to be the gold standard, CLIP, the difference is just crystal clear. CLIP works by pushing things that are different away from each other, but JEPA works by predicting what's missing. This makes it way more efficient, and it encourages the AI to learn abstract ideas, ignoring all the distracting stuff like weird lighting or background noise. And it's not just about being more efficient either. In these tests, where the AI had to figure out what action caused a change between two pictures, kinda like common sense physics, VL-JEPA actually beat GPT-4, Claude, and Gemini. And why? Because it could just reason about the meaning directly, instead of having to first describe what it saw in words and then reason about its own description. It just skipped a step. So where does all this go from here? Let's zoom out and look at the big picture for a minute, and that includes talking about some of the really important limitations here. Now, let's be clear, this isn't some magic bullet. A lot of critics rightly ask, is this true understanding or is it just really, really good pattern matching? Others point out that you can't truly learn about the world just by watching videos. You need to actually interact with it. And it's so important to remember, this is not a replacement for models like GPT, which are still way better for deep, complex thinking and planning. So really, the big takeaway is this. The goal here isn't to replace language models. Not at all. It's to build a totally new kind of intelligence, one that's built from the ground up for tasks that are heavy on perception and need to happen in real time. Exactly the places where being forced to think in words is a massive bottleneck. Ultimately, what this all points to is a philosophical shift. It suggests that the future of AI might not be about getting better and better at predicting words, but about getting better at actually understanding the world. It's a bet that meaning comes first, and language is just one of the tools we use to share it. And that leaves us with one final thought to chew on. As this kind of technology grows, how is a world full of devices that can understand meaning directly without that slow, clunky translation layer of language? How is that going to change the way we interact with tech every single day? That's something to think about.